Hello and welcome to the Unmanned Ground Vehicle Sensor Integration Team's video sponsored by EquipmentShare. EquipmentShare has tasked us in creating an autonomous ready skid steer. By this, I mean we're tasked with making a skid steer that has all the systems in place to be ready to be autonomous, minus the code to drive the vehicle. To do this, we plan on using a radar and two auxiliary cameras. But due to the radar being a prototype and not being ready come January, we redesigned the system to use a LiDAR with two additional cameras. To interface between the vision subsystem and the vehicle, we used the NVIDIA Jetson TX2 to connect to the vehicle via the CAN bus. In addition to a computer simulation to mock the real-life design, this is what our project entailed. I'm Mark Carapino and I'm a systems engineering major.
I'm Eric Patterson. I'm an electrical engineering major.
Hi, I'm Al Cracchiolo and I'm a mechanical engineering major.
Hi, I'm Gabriela Becerril and I am a systems engineering major.
I'm Bowen Saleh-Cal and I'm a mechanical engineering major.
Hello, I'm Zishen. I'm in electrical engineering major.
Our approach to the problems of this project were to research materials to ensure they would meet the specs required, test those materials, and ensure the overall function of those materials in the system overall. On the screen, you can see some of our preliminary designs. Throughout the project, at the request of our sponsor, many changes were made to the overall system. We will show you how we responded to these changes with flexibility and ingenuity.
Our major requirements state that our system must withstand shock, vibration, and bearing temperatures. The performance requirements specify that the LiDAR is to be integrated onto the track loader and operate at its maximum potential. Additionally, we were required to operate the basic controls of the track loader. For this simulation, we are meant to demonstrate all components intended for the physical system of this project.
In the first picture, you can see our Wacker Neuson skid loader with our point design integrated. The cage is made of 1/4-inch steel bars and secured to the loader using 5/8-inch thick grade 8 medium carbon alloy nuts and bolts. As you can see, there are several cross members running over the top of the cab to make sure the structure is rigid and also supports the heart of our project, our LiDAR. The LiDAR and its enclosure are lifted nearly a foot above the top of the cage for maximum vision performance. The LiDAR is protected from rocks and other debris that may be found in the workplace by 1/4-inch steel bars welded to the bottom cap. The enclosure is capped on each end with a 1/4-inch thick steel measuring 6 inches in diameter. Here you can see the PicoFlex camera and the enclosure attached to the front of the cab and the rear hood. These are here to cover close quarter proximities that are not covered by the LiDAR. The enclosures are ordered straight from a MasterCar and modified with our 3D printed holding tray that holds the camera right up against the plastic.
A test plan to ensure that the digital I/O signals perform the correct functions to operate the vehicle was created. These signals, when sent to the machine control unit, would test all functions of the vehicle under the control of our system. A series of LiDAR tests were performed to ensure detection distances for humans and vehicles. These tests were performed with and without the acrylic protector. These tests confirmed that the LiDAR would not be able to see through the acrylic, contrary to what our research had predicted. This discovery is what led us to change the acrylic shield to a wire shield, which performed as well as the LiDAR with no shielding at all.
In testing of the Camboard PicoFlex camera, we found that it can capture a clear image when held directly against a 1/4-inch clear polycarbonate sheet. An IP67 rated enclosure with a clear polycarbonate cover would allow these cameras to capture data while mounted on the track loader.
One of our major system requirements is to ensure that the system meets IP67 water and dust ratings. Luckily, our new Velodyne LiDAR system meets these requirements straight from the factory. The cable junctions, however, are to be equipped with IP67 rated grommets straight from a MasterCard.
One of the results that we obtained in SolidWorks was a stress analysis on the LiDAR enclosure. The enclosure had a displacement of about 0.21 inches with a 4,600 Newton force applied to the top of the enclosure. The factor of safety that we obtained on the analysis was greater than 3.5.
The system requirement for the shock resistance and the vibration will be tested together by placing the Trixel accelerometer on two different locations, which are on the top of the LiDAR housing and on the top of the outbuilt metal structure, but right next to the LiDAR housing. After replacing the accelerometer, let the track loader run in both grass and the rubber ground in high and low speed, steering in different directions. We use the accelerometer to collect the data after the 5 to 10 seconds and 1 to 2 seconds after the vibration started.
From the project, I learned how to flash the JSON-TX to like installing the Ubuntu system. I also learned a lot of commands line to build the software from the source code on the JSON. Here's a picture flashing the JSON-TX2 successfully. Another is testing the PicoFlex camera software. The timing of each aspect of a project could affect the section of the entire system. So the earlier you communicate with your partners, the less time you solve the problem. This project also offered us a great chance to cooperate with engineering from the different fields.
This project granted our team the experience of learning to work the way around a track loader, from dismantling the interior to operating the bucket mechanism to lift the cabin. Creating a simulation was also a first for the group and gave us an opportunity to explore the subject.
When working around heavy machinery, it's extremely important to take the necessary safety precautions. This includes, but is not limited to, keeping a safe distance from the loader, especially the boom, while it's in operation. As far as fabrication, always be sure to wear eye and ear protection when working in the machine shop. Failure to do so can cause serious injury or even death, so it's important to be smart and completely aware of your surroundings at all times. Regarding the electrical side of the project, we took many precautions in testing and ensuring proper power delivery to the system. Overpowering can cause expensive and irreversible damage to the components that we either purchased or were supplied with from EquipmentShare.
For our deliverables to sponsors, to document the technical data package and our final report will be delivered by May 4th. And for the track loader, the LiDAR system, the cameras, and the control units, those will be delivered to sponsors by May 7th.
We want to acknowledge EquipmentShare for giving us plenty of support on the changing of our project and allowing us use of different types of cameras and the skid loader. We also want to acknowledge our mentors, Dr. Mike and Ben, for being a great source of guidance and support. And lastly, we want to thank you for listening to our presentation.